Now let's talk about Monte Carlo simulation. Monte Carlo simulations are used to model the probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables. It is a technique used to understand the impact of risk and uncertainty in prediction and forecasting models. The history of this simulation dates back over 5,000 years to Chinese war games called Weiqi. Around 1780, the Prussians used simulation to help train their army. Since then, all major military powers have used war games to test out military strategies on the simulated environments. From military gaming arose a new concept called Monte Carlo simulation. It was developed during the 1940s as a quantitative analysis technique by Drs. John von Neumann, Stan Ullman, and Nicholas Metropolis at Los Alamos National Laboratory to solve physics problems that were too complex or too expensive to solve by hand. The first application of Monte Carlo simulation was to study neutron behavior in fissionable materials. Because their research was top secret, the scientists needed a code name for their new tool. The scientists came up with Monte Carlo because the behavior of the neutrons reminded them of the roulette wheel, and Dr. Olam's uncle spent a lot of time gambling in Monte Carlo, Monaco. There are 5 steps to follow in employing Monte Carlo simulation. Step 1, establish a probability distribution for important input variables. Second, building a cumulative probability distribution for each variable in step 1. And third step, establishing an interval of random numbers for each variable. Step 4, generating random numbers. Step 5, simulating a series of trials. These are 5 steps we'll follow in using Monte Carlo simulation. Now, let's take an example of this Harris Auto Tire. Harris Auto Tire sells all types of tires, but a popular redial tire accounts for a large portion of Harris' overall sales. Recognizing that inventory costs can be quite significant with this product, Harry wishes to determine a policy for managing this inventory. To see what the demand would look like over a period of time, he wishes to simulate the daily demand for a number of days. The first step is establishing a probability distribution. One common way to establish a probability distribution for a given variable is to examine historical outcomes. The probability or relative frequency for each possible outcome of a variable is found by dividing the frequency of observation by the total number of observations. The daily demand for radial tires at Harris Auto Tire over the past 200 days is shown in this table. We can convert this data to a probability distribution if we assume that the past day demand rates will hold in the future by dividing each demand frequency by the total demand 200. So here's an example, and we have 200 days of observations, and at that time there's no demand for this tire, and there's 10 days, and one tire 20 days, two tires 40 days, and so forth. And we want to calculate the relative frequency by dividing this frequency by the total number of days that we have. Then we have this probability of occurrence. And again, these are from historic data, and we assume that the past data would hold true in the future. But if you think, suddenly a calamity like COVID-19 strike, then this assumption is groundless. Now, the second step is building a cumulative probability distribution for each variable. So once you have this probability from your historic data, now you have to build a cumulative probability, meaning that what is the total probability from the previous rank and the current rank altogether. So for example, for category daily demand 0, we have 5%. Since we don't have previous category, we are going to just leave 5% as cumulative probability. However, for daily demand 1, we have 10% of that, and that's 5% plus 10% gives you cumulative probability, so which is 15%, right? And for daily demand 2, now 15% plus 20% gives you 35%. If you go on like that, at daily demand 5, you see 15% plus 85% gives you 100%. So cumulative probability has to end in 100%. If you have done that, now let's go to step number 3. That's setting random number intervals. Random number interval is to assign a set of numbers to represent each possible value or outcome. So we have this cumulative probability, and we want to change it to a natural number. So what we do is we just multiply this one by 100, and that gives you 1 to 5, and the 6 to 15 is second interval, and 16 to 35 is third interval, and so forth. And 86 to 100 will be your interval for category number 5. Then now we can go to step 4, generating random numbers. We want to generate random numbers because we do not know what is going to happen on a certain day. So we have to rely on a random number or chance, and we are creating these chance numbers using Excel. It's quite straightforward to do that if you have an Excel, or you can do that with a Google Sheet or any spreadsheet modeling tool as well. Then, if you have created random numbers now, assign those random numbers and look up the right values for simulated demand, and you are able to now complete your simulation and see what kind of impact you are going to have under this probability scheme. That's what is going to happen at step 5. So this is an Excel work, and I'm going to uh, shortly show you, demonstrate how to do this using Excel. Thank you.